Okay, today's session is in reference to troubleshooting. Our objectives is going to be to describe how to effectively troubleshoot using the 6 steps of troubleshooting methodology, using troubleshooting steps and methodology to diagnose a motherboard issue itself. So, open-ended question here. You guys can answer that. What do you think it means to troubleshoot for you?
Diego, I can't see your screen. It's just black.
So like kind of solve a problem.
You can't, okay, can you get to the Nearpod session while I'm trying to also do the sharing the screen? I'm not sure what happened there. We'll go here then. Can you see that?
Yeah, I can see it now.
Okay, perfect. Thank you. So if you guys can answer in Nearpod what you believe is to troubleshoot to you. Anybody else want to ring in? We got Daniel.
Hit your nose, and that is when you're going to realize that you're making something amazing. The next thing for you to do is to make some peaks, and this is a crucial step. I'm basically
Okay, now we're getting some things. Yeah, so obviously from here, we're kind of all are getting to the actual thing. Eventually is to solve a problem, there is a thing. And as we learned previously, IT professionals spend 75% of their time troubleshooting, tackling tickets, or communicating back and forth, and or planning their day. So it's pretty much most of their time that is spent within these things. It can be from just a simple thing as a failure of a CPU fan. It can be more complicated issues with the actual motherboard. But ultimately, troubleshooting is a logical form of problem solving. When troubleshooting is applied to a computer or any kind of technology, it is the process of using logical problem solving to fix a reported failure. Key word is reported failure. We don't go and start trying to create other issues by trying to determine what we believe is some other type of problem. We try to concentrate on exactly what was reported and fixing that issue. Methodology. Pablo, if you can help us out with that, this slide, please.
Yeah, so methodology, the methodology that you learn in this session will prepare you to succeed in every other session throughout the course of this program. It will use the information from the session in drills, practice sessions, and many other technical sessions.
Thank you. So troubleshooting methodology has basically, we have a handout, has 6 steps and 13 rules. We'll be reviewing that soon, but not right now. Carlos, this slide, please.
When troubleshooting a computer, you always want to think like an investigator. How does an investigator think? Share out FT, what might be a risk of taking action too soon?
Okay, thank you. So what might be a risk of taking an action too soon? What do you think about that one, Carlos? What might be a risk?
What might be a risk of taking action too soon? Well, without taking precautionary steps, you might do something that it's going to be a risk. Yeah, you might be taking risks without taking precautionary steps, so it might cause a problem and more problems. So.
Yeah. Also, about if the risk of basically solving the wrong thing, maybe I assume it is a certain thing, and then I just start tackling that, and I waste maybe 2 or 3 days figuring out how to fix that problem, and then when I come back with the user, it's obviously not it, and I've actually maybe made it worse from whatever I've done, because I've actually compounded the issue instead of actually making it better. Thank you. Jordan, if you can help us with this slide here.
Systematic method to troubleshooting. We're going to build a table that will guide the approach that you take to troubleshooting. This is the systematic troubleshooting method that most expert IT professionals use.
Okay. I believe we do have that in there, but we'll now step number 1. I believe there's a handout, so you might want to start taking out that handout and having it ready, which kind of you got to fill out stuff, so you might want to start using that available. Before I go, I'll give you a couple of seconds there. Should be a handout. If it's not attached, please let me know.
When you say handout, you're referring to
Inside
classwork?
Google Classwork, yeah, Google Classwork. If we go to the session of T5, there should be a handout attached to the session.
Okay.
And basically, as I teach you the method of troubleshooting, please fill out the steps that you're going to see there. In addition to the rules that I give you, you'll notice that the troubleshooting rules written in the middle column, please write additional notes in and around the table that will benefit you. The notes that you take on this sheet will be helpful in the future sessions as we apply the method troubleshooting to specific components of the computer, right? I'll give you guys a minute there to finish opening that Word document. You guys have that flow sheet? Able to find it without an issue? Or having issues finding it? I'm going to be also giving you time at one point to go into breakout rooms and work together to make sure you guys got this, but just want to make sure we have that open so that you can start jotting down things for yourselves, okay? All right, I'm going to start. If anybody needs me to stop, let me know. Troubleshooting step rule number 1, approach the problem systematically. What does that mean to you to approach a problem systematically?
So to like tackle the problem in order, try to see what goes first, what you
Exactly.
can do. Yeah.
That's good. That's good. Thank you. That's exactly it. We don't want to just, like we said a moment ago, jump into step number 5, and we've never really gotten through all these steps correctly. We haven't checked. So if we do stuff too quickly and or jump certain steps, we could obviously either, like I said, compound the issue or create more issues than what we want. So if you find more than one problem on a single computer, how might you approach both problems systematically? DeAndre, what do you think about that one? Should I work on both of them at the same time? Should I do it one at a time? How do you think you guys think I should tackle this? If I find 2 problems.
I would think you would have to focus on one at a time, which would be like one that's like the most difficult
Right.
first.
Okay. Yeah, I mean, you would consider which one at least either more difficult or more critical, right? At that moment in time. That is correct. Because if I try to fix both of them, I'm, like we said before, it may create a problem that's even bigger. I want to concentrate on one, and at the same time, as we learned, we always are taking note of what we're doing, because if we do 50 changes and then check to make sure it's fixed, guess what? We're not going to know what fixed it, because we did 50 changes and we waited until until the 50th time to confirm if that worked. So obviously, we also want to keep track of that. Thank you. Only 3 kinds of issues. We have the user error, we have a software failure, and we have a hardware failure. Now, what I do enjoy is in the IT field, we always have our own little codes for everything. And number 1, user error will be about maybe I don't want to exaggerate, but about 90% of the time, it may actually be a user error. It can be an ID10T error. That one is very famous, and unfortunately, ID10T errors appear daily. Does anybody know what an ID10T error is? So anyways, in reference to those errors, those will pop out a lot, unfortunately. So you got to be careful that is it a user error? We need to make sure it's not. As I stated before, it could be that the computer is freezing, but it could be that they have over 20 windows open. If they have so many windows open and not enough resources, then guess what? It will crash eventually, right? You only have so much memory. You only have so much hard drive space. You only have so much of everything. So you got to be careful with that, number 1. Next, then we have the software failure. Software failure is self-explanatory, and then the almost vicious one is the hardware failure, which usually gives you those blue screens, and blue screen which they like to call blue screen of death. No? Okay, Christina, step 1, if you could help us out with the slide here.
Step 1, interview the client and backup data. When a client comes up to you with a computer problem, what are some of the questions that you might ask?
So, thinking there, what could be some of the questions that we may ask to users? You guys have any clues from the video of Udemy that we watch, and or hopefully part of the chapter that we read? What kind of questions could I ask a user or client? Open-ended questions to try to get the actual problem, because sometimes they just tell us the solution that they believe is the solution to the problem. So we really want the problem, not the solution.
I think at first you want to. Oh, I'm sorry. You want to go?
I was gonna say, how long has the problem persisted?
Yeah, that's a good one, right? Did it just happen? Has it been happening for a while? Go ahead. I'm sorry.
Or what? I'll say, or what were you doing when it happened? Like what?
Yeah.
Maybe a program you had on. Or...
Exactly. As softly as possible, ask them what application, because we don't want them to get defensive. You'll be surprised if we ask that type of question. What were you doing when that happened? I mean, obviously we're just trying to find out what they use, or like you said, what software were you using? What exactly can you duplicate what you were doing exactly? You're still asking the same question, but you don't want them to get defensive. Sometimes people get very defensive, and then they clam up when you're trying to just ask probing questions. But that is correct. Next one. Anybody else want to take? There's plenty of questions I can ask, right?
You want to pinpoint the origin of where the problem arose. And
Mhm.
also, then after, you would follow up by eliminating several of the options that are not the cause of the problem, and get to that single solution.
Well, we're getting to questions still. When I'm
Oh,
step one, I don't want to get out of step one. So basically, yeah, like some of you just said, when did a problem start? You know, did you have maybe a thunderstorm this recently? If we think it's hardware, right? What other questions could we
You
ask?
can ask them when was the last time they cleaned their computer, because probably the motherboard is dusty and it
Yeah,
got
it
overheated.
sounds like if it's getting overheating, right? Another way we could also ask them the same question as earlier. Of instead of telling them what did you do, I can say, how might I recreate what you were doing when it crashed or when it was happening? And the one very important question in step one that none of us said, unfortunately, which is what we should be doing also. Take a wild guess. Before I open a computer, what should I be doing? Which is a question I should be asking them just in case.
She backed up her data.
Yes, right. Interviewing and backing up data. It's actually in the actual thing. So we want to make sure. And when we're asking them that, we're going to ask them what valuable data on your system needs to be backed up, because sometimes they put it somewhere else. Instead of being in documents, God only knows. I've seen people put it in desktop. I've seen people put it in downloads, believably, instead of in documents. Or it's some of the programs store files in their own directory within the program. So we got to be careful on what is the valuable data that they want backed up. It was pretty good. Thank you, guys. So here are your questions. So basically, these are the type of questions that we should be hopefully asking each of them. Please describe the problem, what error message using displays or failures did you see? And we kind of hit upon all of these, right? Any of these here stick out to you guys that you didn't think of or might have not even thought you might have to ask? I think we hit them all, right? When the problem started, all of these seem to be hit upon from you guys in some way or not, right? So why will you want to ask open-ended questions?
To find out what the source of the problem is.
It gives you more of a chance to like engage with the client, and gives you more of like an accurate description of what could have happened.
Yeah, because if I just ask them, is your computer working? Is that going to give me an answer that's going to help me?
She went to go to Home Depot.
Yes or no question will only give you a yes or no answer. So we really want to give them the opportunity to hopefully give us a clue with the sentences when we ask an open-ended question. It makes them think a little bit more. And at the same time, make sure that they're not giving you solutions of what they believe it is. Because we're not asking for solutions. We're asking what the problem, what exactly is happening. So some of them may just say, oh, no, I'm supposed to get this patch. No, that's not what I asked. I'm asking you exactly what is it that's going on that's causing you to have these problems. You know that some clients obviously begin their own conversation and they're already panicking. So as we discussed, obviously behavioral skill of communication, we need to obviously hopefully remain calm. Sometimes we have to be empathy with them, right? And work with the upset customer first before we get to the problem. So be careful that we just don't frustrate them or even make them get more panicked and worried about something as simple as maybe, restarting their computer and or maybe just restarting the program itself. We don't know what the problem is, but if the user is in that state of mind, we know that we're not going to be able to help them, right? Troubleshooting step number 2, establish priority. So Anyone want to take a little bit of a wild guess about established priority as an IT professional? Let's say you begin by deciding what exactly you need to do first. Obviously, during the client interview, your client may come up with a long list of complaints. What exactly would you do first?
You would focus on, like before, you remember how you talked about like the critical problem?
Ask him like the open-ended questions.
Mm-hmm. So we need to, from the list of complaints, obviously, we need to see what's the most critical, as we said, right? Usually, and or sometimes we might do the inverse, depending on what it is. Maybe the most easiest to fix might have been one of the list of things that they said is to install the latest look on there. But at the same time, they were maybe asking for a patch on the old Office. So we have to also prioritize and look at the list to see what exactly needs to be done, because patching old Office, when they already asked me in another thing to install the latest and greatest Office, I wouldn't do the patch, right? I just get rid of that because I'm just going to install the latest and greatest and most likely download the latest patches for that Office and or program. So whenever possible, set both yourself and your client up for success by articulating the list of possible issues and the order in which you are going to address them. We want to make sure that we're clear in their expectations and what is being done. Why might you need to establish your priorities when troubleshooting? We just said, right? We want to make sure that whatever is really critical to them, be that it may not be a major problem, but it may be critical to them to be done first. We want to make sure that we tackle those fires first. Any other reason you guys think we might want to establish priorities and make sure that our client and ourselves are on the same page?
Maybe if they're like agitated, maybe solving one of their problems first will calm them down a little bit.
Well, yeah, and if I start assuming which one they really wanted first, I could only frustrate them even further, right? Because they just gave me a list and they didn't tell me which is the top. And as us, we need to be able to help them help themselves, because as you just said, they may be frustrated and upset, and then maybe they wanted something first, and out of the list, we went and did what we thought was the easiest thing to do, and then we just only compounded the problem. So we have to be aware of making sure that we communicate fully with the users, especially when they have multitude of stuff that they are asking at one time. There is actually some Fortune 500s on purpose, which also frustrates the user, will not allow for one ticket to have more than one problem. In other words, I want to install Office 2016. I want you to fix this, and I want you to install a brand new printer. Those are 3 tickets. Believe it or not, in UPS, they will make you hang up and call again. Because there's obviously other ways of doing that. There's forms that you can submit that it's the same thing. It's a help desk form for those remedial tasks. And they don't consider those easy things that you could probably do yourself, and or you can create the ticket and it'll get dispatched. That's not an emergency. So then therefore, we have to be able to keep track of everything that is being done. And if we compound everything in one list, we're not going to be able to keep track of which problem was solved and at what time. Troubleshooting rule number 3. Beware of the infamous user error. User error. So when working with computers, remember there are only 3 kinds of issues that I told you guys. And somebody tell me which ones they are.
Is it a user issue? Is it a hardware failure? Is it a software failure?
That is correct. So can anybody give me or has ever had this happen to them. I'm not sure of all of you if you all been there, but a story about you in a time where your computer was broken and only realized that you were making a simple mistake. I'm not trying to insult anybody's intelligence, but could you give me that example, please, of when you were like, oh, you felt, come on, you guys could admit it.
I have one.
Go ahead.
So I put my desktop in an area that doesn't have good airflow, and I've been overheating it a few times, not realizing I didn't have enough airflow. And on top of that, I had a towel on top of it because it's one of those. It's a makeshift made desktop, and I had a towel because I was afraid of dust getting in, and that restricted almost all the airflow, and it just kept overheating until I took it off.
Yeah, it was that like little aha moment, huh? It's like, oops, that might be the reason why this is freezing. But yeah, I mean, we got to be realistic, even ourselves. I'm pretty sure we've done certain things that make us like kind of giggle at ourselves on the mistakes that we've done. So if we can do it, obviously our users have that capability and more to create their own problems with themselves. So we need to be able to segregate that one from the other two, which can be an actual a hardware or a software issue. Troubleshooting number 4, ask about the data. Always back up the data. Can anybody tell me what they realize about this step and what is weird about it? What's weird
It's
about this?
it's considered the rule number 4, but you know, it
There
should be
already
the
is.
first rule.
But it's actually in step number 1. You are correct. It is in step number 1. We've asked them. And again, on troubleshoot rule number 4 is telling us, ask us about the data. Why? Because we want to confirm. So now you told me, okay, yeah, you told me you needed this, this, and this, and this to be backed up. Is that correct? At this step means that I'm most likely getting to the point that I'm going to be doing something physically to your computer, and I want to make sure whatever I'm going to back up is what we agreed upon. That's why it's come back into this step. Because at first we just told them what was the valuable data that they wanted. At this point, we've supposedly confirmed in the previous step, it's not a user error. It's either a software and a hardware. So I'm about to go in there. So now in troubleshooting step number 4, I have here that you wanted me to back this up. I'm going to back it up. Is that all you need? If not, so we want to think about it. Obviously, in our own computer, like I said, it could be anywhere. And if it's critical for you, what you think would be their reaction if we miss out on that? If we don't do this step, what do you think will be their reaction?
Explosive. Anger, maybe.
Far from comforting.
It could be so mission critical that it could almost cost them their job, right? Because maybe they told them that they're supposed to be copying these accounting files to the server, and they only did it maybe once a week. They copied the certain file that they needed, and now this important data has been completely lost. What's not important to us can be important to somebody else. And we're going to find that out in time management too, on how we can balance what's called time management. But we got to be very, very, very careful with data. Data is one of the reasons that can make or break anything that you're trying to work on. Even as simple as just, obviously, if you're just going in there just to check certain things, is not a major issue. Every company has its rules, but this rule, at least for CompTIA and for anybody that is in the technical world, usually you don't want to skip this. I already told you, everybody has their own rules. It could be that your company says if you're upgrading Outlook, you don't need to do a backup. Obviously, if you're just adding a printer, you don't. But if I'm adding a sound card, should I back up? I'm about to add a brand new sound card in this computer. Do you think I should do back up the data on that computer?
Yeah, I get up
Yes.
anytime you open the case.
Right? I'm about to open that case. You best bet I'm gonna cover myself. If I'm putting my hand in there, I'm gonna make sure I have a backup. I'm not touching the hard drive, but I am touching the system. Step 2, examine the system and develop a theory. So once you have interviewed the client, ensure that the data is safe, right? So I stopped freaking out about the actual issue of the backup. Now I'm examining the system and develop myself a theory. What does it mean for you to develop a theory?
Basically, like a education guess almost.
Right?
Yeah.
Like in science, it's an educational guess. So you're gonna have a hypotenuse or not hypotenuse.
Hypothesis. Hypothesis.
You got a triangle now. Sorry about that. I hypothesis, and you're gonna make sure, just like in a science experiment, that you actually are doing it and confirm that what you believe was the problem is the problem. So you'll see these written on your handout, most likely. I think you'll see these inside that handout that we're looking at. You should be able to see the 4 important troubleshooting rules. Rule number 5. Anybody want to give me a divide and conquer? Try to define exactly. So I just basically developed a theory, right? I examined the system and I developed my theory. What do we believe at this point divide and conquer means for us? Now, guys, I'm asking.
Make sure that the device is working properly.
Go ahead, I'm sorry.
Making sure the device is working properly and accomplish the goals that you set to do.
Okay, because okay, we're in a step right now where we're examining the system, right? And we developed a theory. So we're talking about the theory when we're developing a theory itself, yes. And what it is that we need to focus on the idea and as a theory at a time. So if we have maybe 5, like you're saying, 5 things, we don't want to jump. So we're going to work on each theory of what we believe is the problem. And we're going to divide and conquer by thinking at each problem separately and developing each theory one at a time. If we jump in all 5 at a time, we may, obviously, like you said, create more problems. The best way to divide and conquer is that isolate the problem, develop a theory for each, and then basically effectively test one at a time. Confirm, did this fix the issue? Yes or no? No? Go back, right? Go back to the step 2 where we're basically working with our theory. If we have another theory, we go through that theory and do the same all over again. So thinking about the categories of the problem, what first question you want to cold call? What do you think would be a first question you want to answer for yourself? Thinking about the categories of problems, we said 3 of them, right?
Yeah, so the software is working, hardware is working.
Is it software? Is it hardware? And or if it was user, make sure that we were able to determine the 3 of them, right? So if we start going and assuming things without confirming first, we're in trouble. So troubleshooting rule number 6, where it jumps to, is make no assumptions, because the word assume unfortunately hurts you and me, and it just doesn't look pretty. Why is it important to make assumptions when troubleshooting, though? Some assumptions are basically in reference to theory, right? That's
Educated guess.
An educated guess, but we're not going to automatically assume that that is the problem. We got to what? we got to actually test the theory, right? Got to make sure that it is like an investigator, that what we know or believe to be the problem, that it is, and build on upon the knowledge of whatever it is that we previously might have experienced to make sure that we could be able to fix it. So if what kind of assumptions do you think maybe some other IT professionals might make? Can somebody give me a little shout out on that one or share out? One of the ones,
That it was a user's fault.
I kind of hinted it also, right? The user's fault, but there's one more. It could be mine too, right? Because I could start assuming that it's exact same problem that Mike had yesterday, because it looks exactly the same. So I have a little cookie cutter template of what the solution, and I jump in, I'm all happy, and boom, didn't fix the problem. Careful, we as IT field, that we don't assume that that's always the problem. Whatever we believe to be the problem, we need to confirm. That's one of the most frustrating things that could ever happen to you, is if we just jump the gun and don't methodically plan and check everything in every step. So this is one of the things where I was trying to say earlier, but this is in reference to the problem itself. Troubleshooting rule number 7. Always try the most simplest thing first. Why would I want to do the most simplest thing first? We're talking about a problem, not the simplest problem, if not fix, the simplest fix.
It's less expensive and it's usually quicker to do, and I could resolve the issue.
Yeah. So the least invasive measure is obviously going to be the quickest one that's going to do, and it is one of the troubleshooting ways of doing stuff. Before you actually stick your hands in, you can always think about it from the outside in, from the software or the user, right? Then you go towards the software, then you go into the hardware. That's the easiest way to remember it, of what they call least invasive in troubleshooting computers. It'll be a little bit different in when it's reference to network, but when it comes to computers itself and or any other type of hardware that is not a network, the concept is the least invasive is the view from the user, then view it as a software, then go into the hardware itself as whatever the fixes that you're doing here. Any questions? So next one here, Christina, can you help me out with slide 23?
Follow this process to form a best theory and test. Reproduce the problem and observe yourself what the client described. Decide if the problem is hardware or software. Make your best theory as to the source of the problem.
Exactly. Want to be able to reproduce and see it, because sometimes the user is telling you something and you think you understand what they say, but not until you actually see the issue, or they haven't taken a snapshot of the issue, or you actually catch them. Maybe it is that they're opening up those 50 windows before they decide to open up that 51st window. That's basically when it crashes. You'll be surprised. So we need to make sure we're able to reproduce the problem. And as you stated, if it's hardware or software, we got to be sure, because then we're going to start wasting our efforts and time on the wrong thing before we could actually develop the actual theory itself. Thank you. Here's where troubleshooting rule number 8 kicks in, where we become the researcher, where we become basically the next detective. What's this guy's name? Watson or whatever his name is. Dr. Watts. Anybody know what's that guy's name again? Nobody?
You talk about Sherlock Holmes?
Thank you. See, look, somebody's paying attention to me. So in step 8, that's where we're at right now, is basically we become the researcher. We make sure we confirm everything. What might you do to research the problems? Anybody? What things can I do?
Hello.
Google.
Or another
friends,
colleague.
colleagues, right? There's maybe training materials or user guides that the company has, forums, right? As I've stated before, a lot of these companies have a full library of all the different programs or hardwares within their company. And as you stated, the colleagues. So all of those are possibilities. It's 10:19. I'm pausing here. And we're gonna go to the second file that you should see there. It's the scenario. We'll be using that one soon. Hopefully you opened up the first one. I didn't want to confuse you guys at first. I uploaded only one, which you were following along so far. So, so far we've gotten pretty much through certain rules. We're going now into the session, little session here where we're gonna be breaking into our own little groups. We're gonna take that new handout that I just uploaded, and basically we're gonna go into breakout rooms and look at those scenarios that are in there, try to practice with each other the rules that we've just looked at. So we're gonna have two handouts, obviously, the handout that we hopefully had already open that we've been filling out, and the scenario that we're gonna be looking at. So questions or doubts? Anyone not able to find the form? Okay, guys. So from this session that you guys just had, can somebody give me some feedback? What was the best open-ended question someone in your team asked in the scenarios? What do you think was one of the best? Okay, slow down, please. I can't hear you all. I'm gonna have to mute you guys. Nobody said any good questions? Jesus.
Yeah, so questions will be like, did you change anything in the computer lately? Anyone else used your computer lately? Or any changes you did in the hardware or software? Any backup data you want to be backed up?
Mm-hmm.
Like that.
Cool, cool. Nice to hear. What was the hardest part, you think, Daniel, of playing the part of the IT professional? What did you find was the hardest part?
I wasn't like the IT professional per se. I was more of the client. Like,
Oh, so you didn't get to, okay.
No.
Okay, if the persons that were IT professional or got the chance to do IT professional, could they provide you feedback? And what was the hardest part about being the IT professional in those scenarios?
I would say, just like, actually, I wouldn't say it's challenging, but just like sometimes we all have like our days or whatever. So like sometimes we might not feel as sympathetic for like whatever reason, and so that could be challenging sometimes. Like to be like genuine about something that happened to a person's computer and like care to fix it. Make sure that like they know that you actually want to fix it.
Thank you. So, Alexa, which of the troubleshooting rules did you find most helpful? Out of the ones that we've so far gone through in these scenarios, which one did you guys, or did you, your team, find the most helpful?
I would say approach the problem systematically.
Okay. Thank you. Any other one? Or Justin or Teresa, Carlos? No one?
What was the
Probably
question again?
number 7.
Yeah, can you repeat yourself?
Which of the troubleshooting rules that we were using, obviously we only got to a certain step, right? From those rules, which ones did you find the most useful for troubleshooting and the IT professionals? So they made it easier to be able to kind of troubleshoot.
I think number 7.
And can you, for the rest of the class, tell us exactly what is number 7?
Try to do the simple things first.
Thank you.
You're welcome.
A second here. Let's go back to the Nearpod session. Let's see if I find it. So our next in the steps here overall is test your theory. When it's time to test a theory, you want to follow several troubleshooting rules. First, rule number 9, write things down. We need to get catching on to this thing. I'm not sure if you guys are noticing, there's rules and there's steps. So that form that we're filling out, hopefully we're filling it out correctly. When we break out back, we should be able to get this correct. So there's rules for each step. And so we have our steps and we have rules that happen within those steps. We want to make sure in this rule, we're writing things down. Think about the notes that you might write while troubleshooting and repairing a computer. What could your notes include, Justin? What could your notes include?
Kind of like standout problems that you notice, anything that's like a pattern, maybe something like that.
Exactly. Patterns, or at least a brief description of what you believe at this point is the issue. Maybe a diagram of whatever you think the issue is, if it implies to that. And maybe there's a software issue, and maybe there's page numbers where it's a user error, and maybe there's an instruction manual that you could put and write down there in your notes where those numbers are for those user manuals, so that the user can obviously do it correctly. Because maybe, as we said, it may be a user error. They're expecting the software to have something available for them, but in that moment in time, obviously that option or that button is not there. Why do you think is it important to write things down, DeAndre?
It's important to write things down so you can always look back at it at a later time, and you don't have to go off memory, because when you go off memory, it's not very detailed.
Yeah, exactly, right? They help you also, like you said, keep track of what you're discovering, what you did. You don't have to go to your memory. Sometimes is a dangerous thing, right? Sometimes what we recall may not be exactly what is there. So writing down and being able to remember exactly and eliminate those assumptions it's going to be very beneficial. Thank you. Jordan, can you help us here with slide 33?
Write things down. When Generation asks employees about the most important skills for IT professionals, we learned that the ability to take notes and properly document troubleshooting steps was one of the primary skills that sets the highest achievers apart. We are going to have a later session that focuses on note-taking and documentation. For now, know that this task will be critical for your success.
So yeah, basically, as it says there, you know, we've also noticed that the employers are not so picky about the technical stuff, because a lot of times they could teach you the technical stuff that they need. It's those actual important skills that we learn of taking notes, documenting, and our soft skills that make us shine. If we don't achieve these things, then we're just going to be the guy that knows how to do it, but not the employee that we really want to keep. Documentation says everything about the employee, and it says that they obviously are taking their job serious, because taking notes, if you happen to call in sick tomorrow and you were in the middle of something and I have no idea what steps you're already taken or what were your theories or what so far have you come up with, I'm going to have to start up from square one. Doesn't make sense, right? Worst thing about it is also when you just put done to your boss, that doesn't tell them anything. Just basically 3 hours and your note was done. Does that tell me what you did? Troubleshooting rule number 10, don't assume the worst. Instead of assuming the worst, what mindset could you maintain your positivity when working on a challenging issue, Daniel? What do you think? Which mindset could I have instead of assuming the worst?
Diego, can you repeat that? Kind of like lagging out for me a little bit.
Yeah. Troubleshooting rule number 10 is don't assume the worst. Instead of assuming the worst, what mindset could you use to maintain your positivity when working challenging issue?
Gotta have like a positive mindset. You always gotta see, like, you know, the changes, like people, like.
I could, like you said, I what else could I do if everything I keep on doing, this is so challenging to me. Thank you very much, Daniel. Carlos, if it's so challenging to me and everything that I'm doing keeps on, unfortunately, not working, what soft skill will help me to continue, even after failure, after failure, after failure, to try to continue and continue? Which definition or mindset is going to help me, or anyone in the team can help us, that starts with a P, that I can do?
Persistence.
Yes. If I am persistent, if I use that, right? On top of most likely my little creative mindset instead of victim mindset, I most likely be able to the issue, or obviously ask for help to someone in our team, right? Thank you. Troubleshooting rule number 11, reboot and start over. Remember, you may perform steps 2 and 3 several times before you actually diagnose the issue. Anybody remember what steps 2 and 3? Well, steps 2 and 3 are, we should have it in the form, hopefully, Andy. Steps 2 and 3, not rules 2 and 3, steps 2 and 3.
Establish your priorities, number 2, and be aware of user error, number 3.
Are those rules or steps?
Didn't you say steps?
Examine the system and develop a theory and then test your theory. Those are the steps.
Wait, what?
There's rules and steps that it gets confusing, but we're going to make sure we fill out that form together at one point. But I believe those sound like it. Yes, it gets confusing because there's also steps inside this. I don't know. That's why I want.
Okay, I thought you said steps.
Yeah, I could have, would have. I'm not sure. I'm not in that slide right now. But I can guarantee the one that Daniel says, I believe, sounds like the correct ones. Those are the actual steps, which is establishing your theory, and then I believe test your theory. Is that a correct statement there, Daniel, you said?
That is correct.
Thank you. Step 4, plan your solution and then fix the problem. That's the actual step 4 now that we're in, believe it. After I don't know how many rules so far, right? So step 4, from what you guys,
Daniel said he'd be back.
I'm sorry?
Daniel just put in the chat that he'd be right back.
Oh, okay, no problem. Thank you very much for letting me know. So you have been persistent, as we said already, and you've tested your theories, and you've discovered basically that one of them might be right, and it's time to fix the problem. So now we're getting into step 4. We're planning your solution, and now we're going to fix the problem, right? So why is it important to create a plan before you begin fixing your computer, you think?
If it doesn't work, you had a backup plan.
Exactly, right? You want to make sure if your plan you're choosing also has the best repair option, right? Because you're testing your theory and everything. And also you want to make sure that we have the right parts and supplies, because if it is a hardware issue, should I be opening up your computer or taking your computer away if I don't have the parts? So that's another reason why we should plan your solution and then fix the problem. Want to make sure that we don't jump the gun. Thank you. Now, troubleshooting rule number 12. So 12, if we're starting to catch on, is inside step 4, right? So use the least invasive solution first. So a little while ago, we talked about the idea of trying simple solutions first. We're going to obviously discuss this idea by applying it to creating a solution to fix a problem that you might have diagnosed and confirmed. What does it mean to you to fix the least invasive solution from what we have heard so far, Alexa?
You said it, which one of the troubleshooting rules?
Correct, but what does it mean to you to do the least invasive solution first? What does it,
To do the easiest one first.
yeah, easiest, less effort, right? For you.
Yeah, basically not actually having to go inside physically the computer.
Yeah, exactly. That's the way we know that. Unless if it's hardware, obviously, then we got no other option. But either which way, whatever our different solutions that we've come up with, we should try the easiest, least amount of effort first. Confirm that it works, and obviously, then proceed to the other steps if it didn't, right? Make sense?
Yep.
So, Carlos, can you help us out here with this slide? No, actually, no. That was what I just said. That's a verbatim of what I said. Sorry about that. Troubleshooting rule number 13, knowing your starting point. So rule number 13, Pablo, what do you think that means to us exactly? Remember, again, the importance of least investment measure, finding out what does and does not work before you start a computer to take it apart and stuff or doing anything, knowing your starting point. How would that help us?
So like if you know your starting point, let's say a customer
I'm about to take the computer apart. So the starting point on that, what would you think would be the most important step there? I'm about to take the computer apart. I already did backup, right? So we're here in this step where I'm testing the theory. So your backup, all that stuff is done. Basically unplugging, doing all the right proper steps. But now I got that lid open. What do you think is the most important starting point there? Thinking about it there. What's the most invasive thing that I could do before I even touch anything? Did you see me?
No, I didn't.
Right? I would take a picture. That's the first thing I want to do, right? Making sure I have my order of steps and where I'm going to start from. What is it that I'm going to take out? I got to make sure that the screws that I'm taking out are the right ones, right? All that stuff. I got to plan exactly in the steps that I think I'm going to do it. I'm not going to be writing all these things down, but I got to think about it logically. What is it that I'm doing? Usually writing things in planning, it was the theories that we had with on that point. And since it's usually high level, what we're saying, we're writing down to ourselves. Basically, we want to make sure that whenever step we're in at that point, that we have an idea of how we're going to be taking this computer apart, what is it we're going to do, and have that plan accordingly so that we don't jump in like anything else into the last step first instead of the correct starting point. So, like I just said, remembering obviously the importance of the least invasive measures. We want to think like an investigator, be methodical when you begin taking apart the computer. And obviously, as soon as you have a plan, it's time to fix the computer. Step 5, not to be confused with Rule 5. Verify and fix and take preventive action. So in step 5, after the problem has been fixed, we supposedly did everything and finished with all of the previous steps, right? We're now rebooting the computer. We're going to check the system, verify that everything's been fixed, working properly, looks beautiful. Have the client check. It's not that me. I think that everything's good. It's fine and dandy. Now I got to get the buy-in from the client. I can't just assume that that was what I believe was the problem. I believe it was. It's been fixed. Now we got the client got to buy into this. And then ask yourself, if this could have been prevented, that is one of the other questions you got to ask yourself. Could this have been prevented? Is there something that the user, all kidding aside on user errors and their error assigned to them, we must be able to educate the user so that if it's performance updates, if it was something that they could have avoided, they could have stored the information on an external hard drive before they ran out of space and the whole thing crashed, stuff that they could have seen on their own. We want to make sure we educate the users because we don't want this to come back again. Remember Einstein said, if you continue to do the same thing over and over again and expect a different outcome, insanity is the only thing that you have as a result. Questions on step 5, verifying the fix and take preventive action. Step 6, document what happened. Document, document, document. So once you have obviously fixed the computer, you got the buy-in from the customer, and you resolved it, now obviously it's time to document. So you already document. I know you read it, right? Or you wrote it on the previous steps. Now you're going to say that you did what you said you did, you said. Just like we learned earlier, right? In any type of writing, there's always the hypothesis was in the beginning, right? So you could say that's the first paragraph of your story where you say what you're going to do, right? The middle of your story when you're writing a story, or the middle paragraph would be that you do what you said you were going to do. And then finally is the conclusion. That's where we are. We're in step 6. Conclusion is going to be document what happened. You're going to write exactly all more or less a verbatim. I'm going to put step by step, no, but you're going to say more or less that yes, this theory, yada, 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 worked, and that's how we fixed it. Note taking is everything, guys. That is what we get paid for in the IT help desk. We don't get paid for only just to fix things. We're there to make sure we document, because a lot of these analytics that are out there, when these tools are used correctly, there's templates that come out. There's also preventive maintenance that gets done. Things get assigned to programmers that are in charge of software. with our documentation. Questions, doubts? Step 6. So what should we do in step 6? Justin?
Can you repeat that?
What should we do in step 6?
Document what happened, why it happened, and the solution you came to, how to fix it.
Thank you. Troubleshooting steps, memory exercise. So I'm going to break you guys up into your rooms. You got the little sheet. Here's your little answer sheet of the troubleshoot steps memory exercise. Identify the problem, develop a theory, test the theory, establish a plan of action, verify functionality, and take preventive actions. Next was to document findings. Okay, each of you is going to come up basically with a let me see, most likely here. Here's the chart. Each of you are going to be filling out the form together, working on it as a group. You have your steps, so you should hopefully be able to go back and forth with your steps and or reviewing it, okay? Here we go. 1 second here. Was it beneficial? Were you guys able to, now with that little chart, be a little easier to fill it out and understanding the flow of these things? If we notice, we have here a flow chart that hopefully we've learned how to read. Can anybody tell me what's the difference between these objects here? Just reading the flow chart itself. What does the square mean for you compared to a diamond or a rounded object? Lazaro.
Yes, sir. So the round object is, well, the whole big picture of, hey, is it broken or is it fixed? The squares is more of like process thinking and planning. And then the diamonds is, okay, what is the scenario? Is it fixed yet or is it not fixed? As in like a if
Yes or
function.
no? Yes or no, exactly. So the diamonds are yes or no. Your flow charts, we need to learn how to create this. So this would be maybe something that they may ask you, not this specific flow chart, but any flow chart. When they're asking you to create one, IT professionals should know that this little rounded object inside your PowerPoint presentation means that it's either a stop or an end of a certain thing. The square or rectangular shaped thing here, usually only one way to go. There's no choice to be made. If not, you're just stating something in it. When there's a decision to be made, you'll notice that now they have changed it into a diamond shape. It's either yes or no, and now you go either way. And then anything that's continuing a flow has, again, the rectangle. Lastly, you have your arrows, which is easily to be read as where we're going and which direction the line goes. Any questions on how to read or create a flow chart? For the steps overall, does it make sense? Is it start to hone in from the videos that hopefully, or the pages you've read, are these starting to make sense and what they're talking about, and where the tricky part is that in step 4, you obviously could go to step 5, or you might be back to step 2. No questions, doubts? You sure? Okay. Christina, can you help me here with this slide?
As an IT professional, you are working on a computer that will not produce audio. You have already interviewed the client and learned the following. The audio stopped working 3 weeks ago. It was working and then suddenly stopped. The client hasn't seen any error messages. The client hasn't made any updates or changes to their machine. The data on the machine was backed up an hour ago.
Okay. Can somebody share out what they believe is should be our next step, more or less, and or what we may have as a theory?
Since there's no detection of an error on the computer, the first thing I would test is this a human error?
And maybe
User error.
yeah, maybe they're on mute, right? What's another thing I could do? Thank you.
It could.
Someone else? Someone else? Someone else?
Maybe if they're like plugged in, see if the wire's connected properly.
At least invasive again, right? Daniel? What can
Yes.
what are some theories that I can start thinking of at this point?
Repeat that. I can barely hear you. Kind of like bugging out for me.
Theory,
My phone been acting weird.
idea of your diagnose to the given situation. It's not producing audio, and they gave us certain things that have been happening or they've done so far. So what can be some of the theories that we can pop out real quick? Ideas that might come up in this scenario.
Update the drivers, maybe.
That will be more, a little bit more invasive. So we're going a little bit deeper. Okay. Any other things?
Maybe check if it's on the right input or output. Maybe it was changed by accident.
Mm-hmm. Okay. Good. Good.
Being
Yes.
that the client, yeah. I was gonna say, being that the client hasn't made any updates or changes, it could possibly be a hardware issue.
All right. Okay. So here are possible solutions for this. We had one that we really quickly thought was obviously maybe a user error. A virus that infected the system because they haven't supposedly done anything. A bad installation of a driver. Somebody mentioned the driver may be corrupt, right? Configuration problem on the sound card, or a problem with compatibility between the operating system and the sound device. So I think we kind of honed into each one that might be. We went from the least and we came up with other solutions. Obviously, the first one we're going to test is the least one, right? And then progressively go to the next and next and next to make sure. Because that would be very frustrating, wouldn't it? That if I would have went and done all the other stuff first, and then it was only in mute. Or I think Christina said it was unplugged. I didn't notice and it was unplugged in the back or something. God only knows, right? So let's get together again in quick little groups. And you'll be asked to take turns. Oh, no, actually, no. We don't have that type of time. Not about to go into that one. Here we are. I'll jump that one right now. We have our questions. Question number 1. Lázaro, if you can read question 1 and your belief on what is the answer.
Yes, sir. A user's laptop will not power on. Which of the following should you do to help identify the problem? All right. Question the user and identify user change to the computer. I will agree on that one. So we're going to have to eventually select the second one. View system and application logs. That sounds good, but I'm not answering that yet. Inquire regarding environmental changes. That actually sounds better than review logs at the moment. Conduct internal or external research based on symptoms. I will not put D since that's a future step. So since we're in the questioning stage, I will first go with A and C.
Okay, everybody agree? A and C?
Yeah, I definitely agree.
Okay,
Yeah, I agree too.
thank you. All right. Alexa, number 2.
Can I volunteer?
Yeah, sure. Teresa,
Okay. Yeah.
go ahead.
You discover a computer problem was caused by human error. When is the appropriate time to implement preventative measures? A, when documenting findings, B, when testing the theory, C, when verifying full system functionality, or D, when questioning the user.
A, maybe.
So you discovered the problem was caused by human error. When is it appropriate time from all the steps that we've learned to implement preventive measures? So preventive measures, where did we see that?
In step 6.
And that,
Well, no, in step 5, my apologies.
okay, and that,
See then.
and if it's
Yep,
in step 5, where do we believe more or less that is
C then. C.
It will be C.
right? That's
C.
correct.
C.
C. When verifying function, so obviously whatever we did kind of fixed it, but it could have been avoidable, right? It's preventive measures. So at that point, we're at the point of verifying full system and most likely documenting and everything, all that stuff, right? Thank you. Next, who would like to jump into the next question? Volunteers.
Sorry, I lost connection for a while. I wasn't able to hear half of the conversation.
Okay. Well, number 2 or 3 did you miss?
I'm still at number 2.
Okay, not a problem. Number 2 was you discover a problem was caused by human error. When is it appropriate time to implement preventive measures? And we were saying that it was in step 5. Out of the choices that we have here, we believe when verifying full system functionality applies to when we are implementing preventive measures. Because usually when we're already at the point of training the user on something that can be avoided.
Got it. So the answer will be C. We function
Yes.
and then we explain to him.
Yeah. Number 3, I believe, is where we're at now. Who would like to volunteer for number 3? Daniel.
I'll do it. Oh.
Okay, Jordan. Go ahead.
You have implemented a solution that resolved an audio problem. What is your next step? A, document findings. B, verify full system functionality and implement any preventative measures. C, establish a plan of action to resolve the problem. Or D, review system and application logs. Well, C and D can be cut out because those should have been done already. By the time you're already implementing a solution, you should have already established your plan and you should have already done your research on the system that you're working on. So it can be between A and B. I think it's B, but it still could be A, depending on if this is your final solution or if this is just your first crack at, fixing the problem.
I think it's B because we're trying to see if this solution is actually resolved. Let's test it, make sure it's actually working. And then after that, we can do the documentations that it's working fully.
Mm-hmm.
Okay.
Yeah.
Everybody agree?
Yes.
All right. Next question. Question number 4. Who would like to take a stab?
I'll go.
Okay.
You have fixed the printer problem and verified full functionality. What is your next step? Okay, so the final step would be to document findings, actions, and outcomes.
Everyone agree?
I agree.
Okay. Step number 5. I'm sorry, step number 5. Question number 5. Who would like to jump into that one?
During which step of the troubleshooting methodology should you use external research based on symptoms? Is it A, identify a problem, B, establishing a problem of action to resolve the problem, C, establish a theory of problem causes, or D, implement preventive measures? Can I go for B, establish a plan of action to resolve the problem?
You can go for any which one you like.
Yeah, B.
Does everybody agree? B?
I like that option. B, yes.
Yeah.
Well, number 5, we're looking at, all right, let's read this for B. Okay. So everybody agree with B?
I think it's
No,
C.
I think it's C. Yeah.
Okay, so we got some votes for C, some votes for B. Let's look at that one then. During which of the steps of troubleshooting methodology should you use external research? So I'm looking for information and in Google and researching stuff. I'm not fixing anything. So which one tells me that I'm actually doing my research and coming up with ideas of what
It'll be C then.
Yeah.
It'll be
problem?
C.
Everybody agree?
Yeah.
Most likely C.
I agree. Since it's talking about research and a theory is a research when it says establishing.
Good call. So yeah. So let's quickly overview this one just in case. We should be able to see here on your screen. Click the right button. Did I? There we are. I should see it. Now you should see it. Do you see it now? Can you see it? All right, so number 1, we said A and C. We are correct. We are questioning the user and identifying. Number 2 was C, as we stated when we verified. Number 3 was B. Sorry, getting feedback in the background. So number 3 was B. Number 4, document findings, actions, and outcomes. And then lastly, number 5, establish a theory. That is pretty much our session. Make sure I